Welcome to Calculus.
Our stress tolerance level has risen so high that nothing phases us.
On this episode, Stevenson will demonstrate
Here's a situation that can help illustrate the concepts I just talked about. So here's the scenario. The velocity of a particle moving along a horizontal s-axis for the time interval 0 to 5 is given by dSdt, which equals v of t, which equals this function here. Part A. What is the particle's position at t equals 1 second if its initial position is s of 0 equals 9? So this is asking where is this thing located at a moment in time. So in other words, think of it as asking for its new position. Well, we need to know two things. We need to know where did it start, that's the initial position. And then we're going to add how much did it move over the time interval. Well, we'll get to that in a moment. That's called displacement. We know the initial position is given right here. So let's interpret this. This says if t is 0, then s is 9. So when the time is 0, the position of the particle is at 9. So we're going to say 9 plus displacement. So that's how much it changed. So we know it's going to be an integral. Now when does it start? Well, it's going to start at 0, but when is it ending? It's going to end at 1 because it's asking at this moment of 1. So we need to add up all of the change from 0 to 1 under our curve. So this expression will give us the new position we need. Depending on what the problem's asking, you may have to do this analytically, which means doing your antiderivatives by hand. In this case, that'd be reverse power rule. I would rewrite that and then use a U substitution. Or depending on the situation, you may be able to use your calculator. For simplicity's sake, I'm just going to use my calculator in this instance. What's important is that you understand how to set up the problem. So in my calculator here, my answer was 16/3. So this means my particle is located at 16/3, or 5 1/3, on this horizontal s-axis when time is t equals 1 second. Part B. What is the total distance traveled by the particle when t equals 5? Total distance is not the same thing as new position. Total distance means how far did you travel regardless of direction. So we need to make anything negative positive. So we have to use the absolute values. So first we're going to set up our integral. Now when you're trying to find total distance, if you recall in the thinking map, we don't use the initial position, because it's just asking how much distance did the particle travel over a time interval. So it's just an integral. So it's 0 to 5 because it's asking at 5. So we're starting at 0 because our given time interval started at 0. Now we're going to do the absolute value of our velocity function. And the reason we're doing that is because, remember, we want any negatives to be positives. In other words, if this graph, which most likely it does, have any negative values, we want them to be positive because we want all the areas between the x-axis and the curve to be positive, thus giving us the total distance. Now let's go to our calculator and we're going to type this in. Now what's important here is when you type in your function, put absolute values around your function, your integrand here. Okay, don't put them on the outside of the integral, do it on the inside with the function itself. So this is our total distance traveled by the particle when t is 5 seconds. Now let's review quickly. There's two ways you can write this answer. You can write it as 42,586, or in this case, rounding is a possibility. And if there were units attached to this, we might have to read the direction carefully to decide if we needed units.